Journey from the center of the Earth. Going from the core of the Earth towards its surface. The Earth's inner core is a contained sphere about 5,000 kilometers deep within the Earth. Even though the temperature of the inner core is estimated to be as hot as the surface of the Sun, 6,000 degrees Celsius, the enormous pressures keep the core in a solid state. The overlying layers of the Earth cause pressures in excess of 3 to 4 million atmospheres. This solid spherical core is believed to consist primarily of iron and nickel. The outer core, like the inner core, is also composed primarily of iron and nickel, but unlike the inner core, this portion of the Earth is thought to be a shell of liquid metal. The fluid motion of this metallic region are theorized to be the origins of the Earth's magnetic field. The next layer is the mantle, and it is approximately 29,000 kilometers thick. This extends from the top of the inner core to the Mohorovic discontinuity, also known as the Moho or crust-mantle boundary. This region, composed of hot, dense rock, constitutes the majority of the Earth's volume. The main components of this rock, in order of abundance, are silicon, oxygen, iron, and magnesium. The section closest to the core is the lower mantle. This interface between the core and the mantle is pronounced as the Earth's surface and its atmosphere. Rock at this depth is under substantial pressure and is relatively solid, 30 to 100 times the viscosity of the upper mantle. Above the lower mantle is the upper mantle. The pressure and heat in this zone allows rock to flow in what's known as a plastic manner. The rising and cooling of hot, mobile, molten rock is believed to occur in this layer. This method of heat dissipation is called convection. It is considered one of the possible driving forces for plate tectonics. At the top of the upper mantle is an important layer known as the asthenosphere, an area of viscous rock that enables the lithosphere plates above to slide around. Riding over the top of the asthenosphere is the lithosphere. This thin layer, relatively speaking, consists of huge plates that migrate over the surface of the globe. The lower portion of this layer, though solid, is still considered part of the mantle. Firmly joined above to this lower portion of the plate is the layer we call the crust, called the crust. The crust is the thinnest, most buoyant, and brittle of all the layers. Even though scientists can't see the separation between these two connected layers, they know it exists because of the changes in seismic velocities due to density. The seismic boundary is known as the Mohorovic discontinuity. As you progress further outward, you finally reach the surface of the crust. This surface is the Earth's interface with the sky, water, life, and light.